Hello, my name is Colin Matth, and today we will be discussing aqueous ionic equilibrium, problem set 6, question 3, solving for moles to find if a buffer capacity is exceeded. The question is as follows. A 500 milliliter buffer solution is 0.100 molar in HNO2 or nitrous acid and 0.150 molar KNO2 or potassium nitrite. Determine if each addition described below would exceed the capacity of the buffer. We have 2.54 grams potassium hydroxide, 2.54 grams sodium hydroxide, and 6.25 grams hydrobromic acid. In order for the capacity of the buffer to be exceeded, one component would be completely used up in the addition of a strong acid or strong base. In order to calculate this, we first need to calculate the amount of moles of weak acid and conjugate base we have. We can start with HNO2. We have HNO2, and we are given that we have 0.100 moles over liters. And we can multiply it by 0.500 liters because we have 500 milliliters buffer solution. Cancel out liters, and we find that we have 0.0500 moles HNO2. Now we calculate our conjugate base, NO2 minus. We have 0.150 moles over liters. Again, we multiply by 0.500 liters, 500 milliliter buffer solution, cancel out liters. And we have 0.0750 moles NO2 minus. Notice that we are calculating for NO2 and not KNO2. This is because potassium is a spectator ion and is not participating in the reaction. Now we are ready to start problem A. We are given 2.54 grams KOH, potassium hydroxide. We want to first write out a reaction. We can do HNO2 plus OH because we are adding a strong base which fully dissociates, so it's just OH minus, yields NO2 minus plus H2O. Now we want to convert 2.54 grams potassium hydroxide into moles. 2.54 grams times the molar mass, which is 56.11 grams, cancels out grams, and we get 0.0453 moles OH minus. And we can compare this to the amount of weak acid or HNO2 that we have, and we calculated that we had 0.0500 moles HNO2, which is larger than the amount of moles of OH that we just added. As a result, the buffer capacity is not exceeded. Problem B is very similar to problem A. We are given 2.54 grams sodium hydroxide, NaOH, and we want to write a reaction again. The reaction for this problem is the same as the reaction for problem A because we are adding a strong base. NO2 minus plus H2O. We want to calculate moles. We can do this using dimensional analysis. Molar mass of sodium hydroxide is 40.00 grams. Quick calculation for moles, 0.0635 moles OH minus added, which is greater than the amount of moles of HNO2 that we have to counteract the strong base. As a result, since we have more moles OH minus added, the buffer capacity is exceeded. Now we are ready to move on to the final problem, problem C. This problem is quite different than A and B because we are adding 6.25 grams hydrobromic acid, HBr, which is a strong acid. So for this reaction, we want to start with NO2 minus, our conjugate base, plus H plus, the addition of the strong acid, which will yield HNO2. Then, like the other problems, we want to convert 6.25 grams HBr into moles. Using the molar mass, we have 1 mole over 80.91 grams. Grams cancels out. We calculate for moles, and we find that we have 0.0772 moles H plus added to the buffer solution. We compare this to the amount of conjugate base, which we calculated above, 0.0750 moles NO2 minus, and we find that we added more H plus than we have NO2 minus or conjugate base. As a result, the buffer capacity is exceeded. That sums up this problem. Conceptually, the idea behind this problem is to calculate the moles of weak acid in the conjugate base, and then compare the mole values with the moles of what is being added to the buffer. If the moles of what is being added to the buffer is greater than the moles of the conjugate base or weak acid, depending on what is being added, then the buffer capacity is exceeded. Thank you, and good luck studying.